How's my favorite class today, boys and girls? Today, boys and girls, we're going to reinforce a bunch of concepts that we have learned all along. Okay, number one, wind is created on our planet because of the unequal heating of our planet. We used this diagram and I talked about sun's rays are more compacted here because of the angle they hit the earth. They heat the earth up more here. They heat the earth up less at the polar regions because of the curvature of the earth. So there's stronger rays hit, or there's more concentrated rays, sun's rays, hit the center than the polar regions. This creates unequal heating. This creates wind, or an atmospheric cell of circulation. We talked about using this diagram. In a perfect world, if the world did not spin, there would only be two cells of atmospheric circulation. One in the northern hemisphere, one in the southern hemisphere. Air would rise up at the equator, travel along the top of the troposphere to the poles where it would cool, and then run back down along the surface of our planet. But our planet spins. And because our planet spins, we no longer have one atmospheric cell of circulation in the southern hemisphere, one atmospheric cell of circulation in the northern hemisphere. Now we have three. The spinning of our planet creates three in the northern hemisphere and three in the southern hemisphere. I use this diagram to show you guys what those atmospheric cells of circulation were. They were the Hadley cells, north and south of the equator. Below and above those were the next cells, the middle cells, sometimes called the mid-latitude cells, more commonly called the Ferrel cells. And then at the poles, we have the polar cells. So we have three atmospheric cells of circulation in the northern hemisphere, three atmospheric cells of circulation in the southern hemisphere. Now what I want you to get, what I want your take-home to be in this course is the wind patterns that they actually create on the surface of our planet Earth. The strongest, most consistent winds on planet Earth are the trade winds, and they travel in this direction. They are caused just north of the equator, and there is a trade wind just south of the equator. They are caused from the atmospheric cell of circulation called the Hadley cell. The Hadley cell. The Hadley cell produces the trade winds, the strongest, most consistent winds on our planet. Second only to the trade winds are a group of winds known as the westerlies. And the westerlies are caused from the Ferrel cell. It is the bottom part of the Ferrel cell contacting our planet Earth. So we get the trade winds spinning in this direction, and we get the westerlies up here spinning in this direction. And notice this is Cape Breton Island that I marked out so that you get a good overview of this map. Now, what else is there? Well, there is something that you should know about. Right at the equator, between the two trade winds, the doldrums. The doldrums is a place where there's very little wind. There's not a lot of exchange between the trade winds in the north and the trade winds in the south. There's not a lot of wind. You also get another convergence zone that would be up here between the trade wind cell, which is the Hadley cell, and the westerlies wind cell, which is the Ferrel cell. So it would be along here. And it's called the horse latitudes. The horse latitudes. And this, the horse latitudes, is actually linked to the major deserts on our planet. So we know if we go to North Africa, it's desert. We know we go to the south central United States, it's desert as well. And that's linked directly to the horse latitudes. So I hope that helps explain surface currents, air currents along the surface of our planet on this diagram, and I hope it helps clarify it for you. So just to go over it again, strongest, most consistent winds on our planet, trade winds. Second to that, westerly winds. Trade winds caused by the Hadley cell, westerly winds caused by the Ferrel cell. The convergence zone between the two, known as the horse latitudes, and it's linked to the deserts on our planet. Convergence zone between the northern and southern trade winds are the doldrums, and it works along the equator. Boys and girls, have a nice